All right, so welcome everyone to Networking Rants. My name is Tony Burke. I can be found on Twitter at tburke, that's T-B-O-U-R-K-E, and I will put this in on datacenteroverlords.com, which is my blog, although these days I'm doing more screencasts. So today's talk is called Long Distance vMotion is a Dumpster Fire. So you can see the picture of the dumpster fire there. We're going to talk about a couple of things. First thing is we're going to talk about the goal. Why do we do, what's the purpose behind long distance vMotion and vMotion in general? What problems does that cause? And when I complain about things, I usually like to try to put in some sort of solution. So we're going to talk about a better solution to the overall goal, to solve the overall problem that, that does not involve long distance vMotion. So first of all, let's just talk about the goal. So the goal for long distance vMotion is availability. Assuming I spelled that right. So we've got an application and we want to make sure that that application can be highly available. So we might want to run it in multiple data centers, or we might want to run it active in multiple data centers, although you can't really do that with long distance vMotion. But the overall goal is to have some sort of backup plan in case a data center has a problem. So we've got DC1 and we've got DC2, and in between them we have to have a couple of things in order to do long distance vMotion. It has to be less than 100 milliseconds of latency between the two sides. We need, I think it's 655 megabits per second of throughput. And we need some sort of DCI, data center interconnect. So that could be dark fiber, or it could be something like OTV. Basically, we have to make sure that the layer 2 network here and here, we have a layer 2 adjacency between these two data centers for whatever VLANs that the VMs need to run on. So the goal is we have a virtual machine, and on that virtual machine we have an app. And we want to be able to migrate it from one location to the other, just like we do inside of a data center. So that's the goal. Here is the problem. So let's go back. I'll draw a slightly bigger version of that diagram. Data center 1. I'll try that again. So data center 1 and data center 2. DC1, DC2. Now we're going to assume 100 milliseconds between these two, so that's enough to get about across the United States from the West Coast to the East Coast. To make the math simple, I'm going to do 1 gigabit per second. So let's say we've got a 1 gigabit link between these two sides, and we're doing something like OTV in order to keep these two networks layer 2 adjacent. Now the data centers are going to have a series of routers, so I'm just going to draw one to represent the routers for each data center. And each data center is going to announce, either directly or through their provider, a disparate set of public IP address space. So data center 1, we're going to go to 1.1.1.0/24, so we're announcing, let's say we can do that, announce a class C, so 2.2.2.0/24. And these are going to get announced out. Inside the data center, we've got our virtual infrastructure. So we've got a virtual machine here. Inside of that virtual machine is going to be our application. It should look pretty familiar to just about everyone here. We're also going to have a data store. So this could be NFS, it could be iSCSI, it could be Fiber Channel. And inside of that data store is going to be a virtual disk, a VMDK file, that's going to be mounted onto that virtual machine. So that virtual machine needs a disk space, so that typically in VMware that's going to be a VMDK file stored on a data store somewhere. So again, very familiar. So let's say we want to do actually a couple more things about this virtual machine. Let's say it's a 4 gigabyte virtual machine. And let's say that VMDK file is, to make the math easy, 100 gigabytes. So 4 gig of memory and 100 gigabytes of storage. So let's say we want to do a vMotion from one data center to the other. First of all, this assumes that we have layer 2 connectivity, layer 2 adjacency through OTV or dark fiber or something between these two data centers. Now, how long is it going to take us to move 4 gigabytes of memory when we do this vMotion in order to get this virtual machine from that data center to this data center? Well, 4 gig, if you multiply it by 8, is 32 gigabits. If I can do 1 gigabit per second, that's going to be roughly 32 seconds. Okay, so it's going to take us 32 seconds to fully migrate that virtual machine over to this second data center. So you probably already noticed that we've already got a problem here. So even though we've migrated the virtual machine and it only took us about 32 seconds, the virtual disk is still in the remote data center. So 100 milliseconds of disk latency is quite a bit. So we'll need to do some sort of virtual machine or some sort of storage vMotion to get that VMDK file over to a local data store, so we're not having 100 milliseconds of disk latency. And 100 milliseconds of disk latency will cause a lot of problems typically. So 100 gigabytes is 800 gigabits per second, so it's going to take us 800 seconds at the very least in order to migrate that one virtual disk file. So we're talking about 830 seconds, and that's assuming that we have full use of that 1 gigabit per second bandwidth and we're not trying to vMotion anything else. If we are trying to vMotion something else, we're probably going, if we are going to do a live a vMotion from one data center to the other, probably it's not just that application that's going to do it. So or that VM that's going to do it. We're going to do several virtual machines that are associated with that application. So that's going to take quite a bit of time. 800 seconds is quite a bit of time, several minutes. So that's one of the problems. Another problem is, what about my default gateway? So even though we've gotten both our virtual machine and our virtual disk file, VMDK file, we've got them both over into the new data center, my default gateway is probably the router over here. So we can do some things like at the OTV barrier, we can do things like filtering first hop redundancy protocols. So let's say the default gateway here is 10.0.0.1 because the virtual machine's IP address is 10.0.0.100, and then we migrate it over here. The whole point of vMotion is so that we can keep that IP address. So its default gateway is .1, which exists on this router. Using first hop redundancy protocol filtering, we can actually have both routers use the same IP address, and things like HSRP or VRP are not going to go beyond the OTV interface, so that we've got a couple routers here and we've got a couple routers here. We can still make the local router the default gateway. But from the public internet, that virtual machine was probably accessible by an IP address off this publicly routed IP address, which is, for example, 1.1.1.100. So now we've still got our inbound traffic coming in this way and our outbound traffic going out that way. This back and forth between two different data centers, this is called tromboning, and this is something that's quite a bit of a problem. The solution for that typically is something like Lisp. Lisp is a protocol or a standard or both that allows us to translate inside IP addresses to outside IP addresses. Again, just so that virtual machine can keep its IP address when it vMotions to a new data center. So as you can see, this is quite a bit of engineering. This is relying on quite a few products. We're going to have to go for OTV. We're going to have to do Lisp. We're going to have to probably do something else other than storage vMotion to get all this data over from these VMDK files from one data center to another, something like Site Recovery Manager or something. So this is a lot of work. It's a lot of money. It's a lot of complexity just so that virtual machine can keep its IP address. So let me show you a different way. One way, a way that basically everyone, all the different companies like Twitter, Uber, all the .com companies, all the companies that rely on multiple data centers and geographic distribution, this is the way that they do it, give or take. And none of them rely on vMotion on long distance. Long distance vMotion it's a bad idea, but it's also just an ineffective solution to the overall problem. The overall problem is we want an application to be highly available. So let's talk about some current technologies that you can use to keep that application highly available that do not rely on long distance vMotion. So one of the ways that we can do this is that we have to stop treating our virtual machines like pets. You've probably heard this analogy before. We have a virtual machine, and most of our operations have traditionally been we take a virtual machine and we install an application on that virtual machine. Or actually, first we typically install an operating system on that virtual machine, and then we put an application on that virtual machine. And these virtual machines live forever. They're like Highlanders, so they're going to be around for a long, long time. As we upgrade the OS, we just patch the OS. As we upgrade the app, we patch the app. And the problem with this style is that the application and the operating system and the whole thing becomes inseparable. It's very difficult to delineate between application and operating system. It's like we have we've got a bucket of flour, a container of flour, and we've got a container of sugar. Maybe we're making cookies or something, and we put them into a bowl together. We mix them up. Now, when we do that, it becomes very difficult to separate out the flour from the sugar afterwards. Can you do it? Sure, yeah, there's methods that we have, but it's not really, we can't really do it that way. So enter cattle. Now this is kind of a DevOps style, kind of the new style. Pets are the old style. By the way, when we moved to virtualization in the mid-2000s, so about 2007, 2008, that's when we started really shifting our workload to virtualization. The thing that virtualization did for us that really allowed its dramatic rise in IT was it allowed us to keep that pets model. We had these servers and they lived forever, and we were constantly patching them and updating the operating system and so forth. And when we went to virtualization, we could take the physical and move it into the virtual world without changing our model. vMotion was fantastic for this because now I could keep these pets very safe. So I had HA, I had DRS, I had vMotion, and I could keep these long-lasting, everlasting, Highlander-style virtual machines very, very safe. But now we've run into these limitations of, okay, what happens when we need to do some HA? We need to move from one data center to the other. We just discussed all the problems with long-distance vMotion. So there's actually a better way, and it doesn't require retooling too much. It involves more of a DevOps style. So the DevOps style, the cattle style of dealing with virtual machines is we're going to, from the get-go, separate our applications from our servers or our virtual machines. We're going to treat them very differently. We're going to keep them separate. The virtual machine becomes disposable now. The way that we instantiate these virtual machines, rather than going in like VMware and vCenter and creating a new VM and mounting a CD on ISO image in order to do the installation of that operating system, or maybe we've got a snap of it, we're going to instantiate this virtual machine from a pre-built image. And when this instantiation occurs, it's already installed and ready and waiting, and it's kind of like a blank slate. You can do this for Windows, you can do this for Linux, you can do this for any of the BSDs. We put this image somewhere on a repository, so got like a CD, like this is like a virtual ISO image here. So we spin up this virtual machine. The application, that process is different. we're going to use something like maybe Puppet or Chef or Ansible or one of these configuration management, or there's actually other ways we can do this too, but we're going to encapsulate this application. We're going to define this application. The application is also going to be found on a repository like GitHub or even just an SFTP server, something like that. Something where we can get access to it. The developers make code changes, they upload it to the repository, they don't upload it to the virtual machine. Now we're using Chef and Puppet to define the application. So we've got a definition or a manifest or something that includes the application. It includes any libraries and other dependencies. And then it gets run on that virtual machine and the application gets installed automatically. And it's got access to all the resources it needs. It's got access to disk, network storage, and it's got access to any libraries or whatever it needs. And when we upgrade the application, rather than piling on kind of a sedimentary approach, the pets are a sedimentary approach because we've got installation after installation after patch after patch after patch, and things kind of pile up. And we've got a snowflake. And a snowflake is unique, and unique is really bad for reliability. It's bad for predictability. So here we're not going to deal with any snowflakes because we have this definition here of what this server is supposed to look like, what applications we're going to install on it, what libraries, what packages, what RPMs or whatever we're using to install into this virtual machine. And we're going to assemble this virtual machine from a definition from a predefined manifest or some sort of definition. When we're done with it, we can just destroy it. And the upgrade process looks something like, maybe I've got a new version of the code. So, or first of all, I spin up a virtual machine. Puppet or Chef or something goes in and installs the application and whatever dependencies. When we install the virtual machine, by the way, the OS already was on there. It's kind of a blank image. The application and the dependencies get put on there. We've got a running system. Now let's say the developer says, oh, hey, I've got a new code version. So what we do is we spin up a new virtual machine rather than do an upgrade. Spin up a new virtual machine. It's instantiated from a pre-built image, so the OS is already there. The application gets installed. Any dependencies get installed, and we can run a test on it. And if it works good, then we can migrate over our production traffic to that new virtual machine or set of virtual machines and destroy the old one. This is the cattle style of dealing with applications. Now, this virtual machine, the OS and the virtual machine itself, it's mostly dead weight. If you take a look at how much space an application takes, an application is dozens to maybe 100 megabytes. Maybe a little bit more. The virtual machine itself is hundreds of gigabytes typically. So 100 gigabytes in terms of disk space, in terms of memory and whatnot. So this stuff, all the virtual machine and OS stuff, it's dead weight. We don't really need it. I mean, we need it in order to run an application typically. But in terms of, it becomes very heavy, it becomes very hard to move it from one location to another because it takes up so much space. It takes so long to transfer it over a 1 gig link or even a 10 gig link. So if we encapsulate our applications by themselves through these tools, then we can migrate them from one data center to another with much, much greater ease. So back to our data centers setup here. So we've got our data centers. You can probably hear my cat eating in the background. So I've got DC1 and I've got DC2, and it doesn't really matter what kind of connection I have. I need some speed. I don't necessarily need a gigabit per second, but I need some sort of layer 3 connectivity. It could be over a VPN, it could be over a backend channel, something. It doesn't really matter at this point because I don't need to be layer 2 adjacent. I don't need to have any fancy OTV or anything like that. I've got my a virtual machine spun up over here It was spun up from an immutable image. Some tooling, install the application and any dependencies. The OS gets installed. At this point, I don't really care too much about it because it is it's kind of hard to read that. That's OS for operating system. It's just a place to run these virtual machines. Now, let's say I want to do a migration. Well, I can pre-populate the other data center with a virtual machine. And that virtual machine already has the OS on it. And I don't have to wait for a failure. I can just pre-populate this virtual machine with the application and the dependencies. So now I don't even have to worry about vMotion. I'm already set up on the other side. So what about syncing up data? If the data is stored in the application, we have some tooling that we can do to keep them in sync. I can do a shutdown of that application. It'll save the state to local disk. I take all of that, again, with my tooling, and I can do a transfer over to this data center. Again, if it's like a couple hundred megabytes, that's going to be a lot quicker than 100 gigabytes. So it's going to be much, much quicker to transfer. Or more likely, I'm running like SQL Server, Microsoft SQL Server, or a MySQL, or a MariaDB, or something. So I'm going to have a database on the back end here, and all of the database solutions have some form of database sync. So if it's a synchronous database update, it's going to take a little bit longer. If I do a if I do a commit to the database here, so this is a database, then the write does not get acknowledged until it does a full write onto the remote database. At 100 milliseconds of latency, or could be even 400 milliseconds. If you have a lot of latency, that synchronous database becomes a little bit problematic just because of the latency involved. So a lot of times you'll do like an asynchronous database. So this database will be synced up with this database. It'll just be behind in time. So now we don't even have to do a vMotion of our database because they're synced up in a different way. So they'll be sitting on a virtual machine somewhere. And we can use local vMotion to keep that database server very safe. We can vMotion it around. We can do updates on the underlying infrastructure. But now we've got our data synced between these two data centers. The applications get installed from probably a central repository. It could be sitting in one data center or both. It could be synced up. And that's where we get our application code. And we can fetch our dependencies that way as well. And then in terms of directing traffic from one data center to the other, we just use a simple global server load balancer. And the little secret about global server load balancers is all they are fancy DNS servers. They include some extra features like trying to determine where the user come from, what continent, what geographic region. So you can use something like A10 or F5 to do that, or you can sign up for a service. They have this as a software as a service now. So this is how these various vendors, these various companies do HA. And this is a much, much better way to do HA than long-distance vMotion. A much simpler solution, a much more effective solution, a far less complicated solution. Now, one thing you may have kind of noticed here is we have this application. We've separated it out. We've encapsulated it in a different way. The virtual machines become disposable. So what about containers? Containers, yes. This is kind of a natural evolution of this. So we take an application and we take any library dependencies that it has. For example, it might need libSSL. It might need Apache installed. It might need Tomcat. We need the war or jar files, so we need the code itself. And we put this all into a container. And then now we can move it from system to system. It's very portable. The developers love it because they can develop on their laptops. They can download a container, like a raw container, kind of a blank container that has maybe libSSL, Apache, Tomcat installed already. They can develop their application on it. And when they're done with that container, they can send it and put it in production, or they can run some tests on it through tools like Jenkins. So they create the container, and then we can, this container, if it's like a Docker container, I can run it in any environment as long as that server, it could be a virtual machine, it could be bare metal, it could be a VM on Amazon, so AWS, or it can be the part of their container service, and I can deploy it anywhere. Containers are very small. There's not all that extra gigantic VM, VMDK, all that kind of dead weight. That is really not necessary to move. So we get rid of all that weight. The containers are typically dozens or maybe hundreds of megabytes. They're very easy to move that way. They can also encapsulate all of our configuration files and environment variables, such as what version of Python are we going to use, or and all that can be installed, and then we can just put that container wherever we need. They also start up a lot quicker, so a container can start up in just a few seconds and can be instantiated in just a few seconds, while a virtual machine may take minutes to get instantiated and may take dozens, even a minute to start up, which may not sound like a big deal, but if you're doing testing, for example, if I create an application, or I've got an application and I make a code change, a lot of the modern tooling practices that we have is that we're going to run some unit tests on something like Jenkins. Now, if we're going to use virtual machines, Jenkins has to instantiate these virtual machines. It has to spin them up, load up the code, do the Puppet Chef or whatever, run some baseline tests on it, and then return the results. If we're using virtual machines, that can take 20, 30 minutes, even a couple hours. If we're using containers, rather than spinning up and instantiating these virtual machines, Jenkins would instantiate these containers, would run unit tests with other containers against the application and report back the results, and that can take like 5 minutes, 10 minutes. So it really reduces the cycle time, and those it's just a difference of 10 minutes or an hour. But if you're doing a lot of code changes, that really adds up. So that's why containers are becoming very popular right now. Because the operating system, the virtual machine itself, is becoming much less important, and it shouldn't have been important in the first place, because what we really care about is that application. So let's see what we've covered. We've covered the goal. The goal is application availability and flexibility to run in multiple data centers. The problem with, and we talked about the problem, why DCI, data center interconnects, layer 2 adjacency, long distance vMotion is such a dumpster fire. Like this diagram right here pretty well shows you a dumpster fire. And I've showed you a solution, a much, much better way for us to make sure that we have applications that are highly available, portable. This is much more flexible. This is much quicker. This is much more reliable. And all of this is possible if you give up on the notion that you need to keep the IP address on the virtual machine, or that you need to keep that virtual machine whole. So if you can do that, then you're going to be in a much, much better spot. And this is how all the big companies do it. So I hope you found this useful. Again, my name is Tony Burke. You can find me on datacenteroverlords.com or hit me up on Twitter @tburke. Hope you enjoyed. Thank you for watching.